data displays, day 1, bar graphs and circle graphs. Objectives. The students will be able to summarize categorical data by counting the number of cases in each category, expressing these counts as percentages. The students will be able to display categorical distributions in bar graphs and circle graphs. The students will be able to read and analyze categorical graphs, and the students will be able to make circle and bar graphs using technology. You're going to be using Google Sheets. The students will be able to use data given in frequency distribution tables to create circle graphs and bar graphs. Once again, that is going to be in a Google Sheet. The 3 rules of data analysis. Well, they won't be difficult to remember. Number 1, make a picture. Things may be revealed that are not obvious in the raw data. These will be things to think about. Number 2, make a picture. Important features of and patterns in the data will show up. You may also see things that you did not expect, extraordinary data or unexpected patterns. Number 3, make a picture. The best way to tell others about your data is with a well-chosen picture. Displaying one categorical variable. Ways to display them. Frequency table. We'll start with those and make graphs from them. We'll use frequency tables more in chapter or unit 2B. Bar charts today and circle graphs today. When creating a table graph or chart, you must include a title. So make sure you title the graph, and that should be contextual. Label the X and Y axes, including units. Don't just put X and Y, put what they are representing. And number 3, label the tick marks with numbers, if not by 1. Start the scale with 0 and then jump consistently. Go up by 5s, go up by 10s, go up by 3s. But you have to start at 0 and jump up consistently. Graphs for categorical variables. 2A tables, that's a few days down the road, but we'll be doing them. Pie chart today, also called a circle graph. Bar graphs. Segmented bar graphs, we're not going to be using those. Side by side, there's an example of that in our notes. Frequency table. In relative frequency table, first of all, it uses categorical variable. In this situation, it's the item bought. These are the categories: shampoo, conditioner, soap, lotion, hairspray. This is the number of data values in each category. That's counts or frequencies. On the right side graph, that's relative frequency. That's the proportion or decimal in each category. So count refers to frequency. Relative frequency refers to proportions, decimals, or percentages. Frequency tables, we have a couple here. A frequency table gives the counts, which are the frequencies for each category. A relative frequency table is similar, but gives the relative frequencies instead of counts for each category. You're using a decimal. And in this case, they rounded to 4 decimal place. I will probably tell you where to round. Frequency tables, relative frequency tables, more information. Both types of tables show how cases are distributed across the categories. They describe the distribution of a categorical variable because they name the possible categories and tell how frequently each occurs. Percentages are easier to understand and interpret. Here's a pro tip. Relative frequency is just a fancy name for percent, or we'll be using proportion, more likely, which should be a decimal. What's wrong with that picture? The ship display makes it look like most of the people on the Titanic were crew members with a few passengers along for the ride. When you look at each ship, you see the area taken up by the ship instead of the length of the ship. The ship display violates the area principle. The area occupied by a part of the graph should represent or correspond to the size of the value it represents. We should be using just length, not area. Here's a bar chart. We do not have a label at the bottom, but this is categorical data. Bars should never touch. Each bar represents a category, which should be listed below the bar. On the y-axis is the number of data values in that bar. So it could be number of outcomes, it could be frequency, it could be counts. But make sure your y-axis once again starts at 0 and jumps up consistently. Bar charts. A bar chart displays the distribution of a categorical variable showing the counts for each category next to each other for easy comparison. The height or length of each bar corresponds to either the count or proportion of each category. The bars in bar charts do not touch. Typically, they're different colors, but in this case, they have them all the same color. The categorical variable goes on the x-axis, so your bars should be going up and down, not left or right, please. Relative frequency bar charts. A relative frequency bar chart displays the relative proportion of counts for each category. A relative frequency bar chart also stays true to the area principle, replacing counts with percentages in the ship data. Does it look much different? No, it pretty much looks the same. We've just altered the scale. Side-by-side bar charts. A side-by-side bar chart displays the relative proportion, in this case they're using percentages, of counts for each category. It pairs a different situation for each category for easy comparison. This chart shows the conditional distribution of survival for each category of ticket class. So the alive is the turquoise and the dead is the purple. And each class, first, second, third, and crew are all represented in that graph. Here's a bar chart summarizing the movie genres of the 891 MPAA rated movies released in 2014 and 2015. Not quite as old data as sometimes. Were thriller, suspense, or adventure films more common? So look for them, for their bars, down at the bottom. Thriller, suspense, I found that. And adventure, where's adventure? Adventure's lower. So thriller, suspense was more common. Which category was most common? Well, that's really easy to check because the bars are going from tallest to shortest. We'll be using that later as a Pareto chart. So that is drama. There are two pairs of categories that were almost identical in counts. Which one had about the same count as documentary? That would be thriller, suspense. And which one was about the same as action? That would be adventure. Another example. Katie is reading a 200-page book divided into 5 chapters. Bar graph shows the number of pages in each chapter. What percent of the pages is in even numbered chapters? So there are 2 even numbered chapters, 2 and 4. And remember, the total number of pages is 200. So if we add those 2 together, the 30 and 70 is 100. And we want to know the percent that are even. So we're going to have to divide the 100 by 200, the total, and we're going to get 50%. Bar graph shows the number of breakfast sold each day. Based on the information shown in the bar graph, which value is most likely the difference between the number of people who purchased eggs and the number of people who purchased oatmeal over the next 3 days. Okay, this is per day in the graph. We want to know over the next 3 days. So let's look at eggs. There's about 100. That's the best guess we can do for that. And it does say about. So about 100 eggs per day for breakfast, which in the course of 3 days would be 300. Oatmeal is over here. It's pretty close to 60. So about 60 per day, multiply that by 3, would be 180 over 3 days. And they want the difference. So we're going to have to subtract those, and we get 120, and that's our answer. Charts and graphs, ACT practice problem. Number 4. Between which two consecutive months was the change in total rainfall the greatest? Doesn't say increase or decrease, it just says the change. So let's see how it changes. From May to June, it went up by 3. But from June to July, it went down 1. Let's see, that went up 4. This went down 6. And that went up 1. So the biggest change would be from August to September. Based on the information presented in the graph above, what is the approximate average monthly rainfall in Bellevue, Illinois, for the period given? So average, we're going to be doing a lot more with average down the road, but you add them up and divide by how many there are. So 1, 2, 3, 4, 5, 6 months. So we need to add up all their rainfalls and divide by 6, and our average is 4. Pie charts. Categorical variable again. Each slice represents a category. Percentage or proportion. I prefer percents when you are making the bar graphs of the data values in each category. It says include a key or legend for each slice. I want you to label each slice, and don't forget a title, and the title should be in context. Pie charts. When you are interested in parts of the whole, a pie chart might be your display of choice. Pie charts show the whole group of classes as a circle. They slice a circle into pieces whose size are proportional to the fraction of the whole in each category. Here's an example. Which table represents the data at the right? So we are giving counts, we are giving in the diagram categories, but no percentages. So we've got to think about how big they are. So I would go with the biggest one. Original is the largest. So in A, original is not the largest. B, it is. C, it's not. And D, it's not. So B is the table that represents the data. Here's another one. If there are 300 7th graders, how many students prefer choir? So choir is right there. It's 32% or 0.32 times the 300, which is 96. Here's another one, number 8. James asked random people about their favorite color. The results are shown in the circle graph. 120 people responded that green was their favorite color. Because we don't know how many people are actually in the survey. So we can figure that out though. So green is right there and it's 15%. So green is 0.15 times X. Gives us the 120 people altogether. Divide both sides by 0.15 and there's 800 people that were surveyed. 25 of those that said they liked yellow is their favorite color are teenagers. So yellow is 25%. 25% of the 800 people is 200 people. But 25% of those are teenagers. So we need to calculate 0.25 times 200. So that'd be 50 teenagers. So what can go wrong? a principle. The graph on the left shows data on a slant, making it much more difficult to compare fractions of the whole made up of each class. So make your graphs like those listed on the right, please. Do not make your graphs look like the one on the left. Keep it honest. Make sure your display shows what it says it shows. This plot of the percentage of high school students who engage in specific dangerous behaviors has a problem. Can you see it? The sector for use of alcohol is supposed to be 50%, which should be half of the entire graph, and it doesn't appear to be that way. Here are the assignments. There's a Google Sheets assignment. You are going to make 4 graphs total, 2 bar graphs and 2 circle graphs. There are tabs at the bottom of the Google Sheets that you will have. It's a 40-point major grade. It's 10 points per graph, and it has specific requirements, so make sure you pay attention to that. There's a quizzes assignment. It's 19 questions, 10 points based on what you've earned, and of course you can always take that up to 3 times.